The Transopto optical link fits in the palm of your hand and weighs in at about 1 kilo. It can connect to any other node visible within the 270 degrees field of view through the panoramic window. If you look inside the box, you'll find the optical module mounted on a pan tilt gimbal mechanism. In addition to the 270 degrees pan angle, we have 20 degrees up and down in the tilt direction. On either side of the lens, you'll find an infrared beacon LED. These are used for automatic alignment and tracking. We will revisit this later in the presentation when we show how the links can be commissioned from a remote network operations center. In this installation example, we want to provide 1 gigabit internet to the remote house seen in the bottom right corner. We will use the Transopto link to connect it to a nearby house which already has fiber internet from the local ISP. The houses are separated by 130 meters. We have already completed installation at the remote house. We will now proceed to the opposite end and show the installation of the other node. Installation is a simple matter of securing the node with 4 screws. From here, we can look towards the opposite node to which we want to connect. We will do this by logging on to the management interface. To align the nodes, use any browser and log on to the IP address of the node we just installed. This brings up the user interface from the internal web server. The alignment is camera-based, and the laser beam points where the crosshair center is. The field of view is narrow to provide good resolution for the beam tracking. However, this makes it difficult to understand where we are pointing. We therefore use the motorized gimbal structure to take images from different angles and stitch these together for a panoramic view. Remember the beacon LEDs on each side of the lens? These are the bright spots visible to the left on the corner of the house. We select this position and bring up the alignment page. So the beacon LEDs are used for alignment and tracking. We adjust the camera exposure to eliminate any other light sources. We then go back to the alignment page and press the auto button. The algorithm will find the beacons and point the laser beam right between them where the lens opening is. We can see in the lower left corner the received signal power from both ends. An optimizing algorithm will slowly fine-tune the beam using the MEMS mirror. For this 130 meter link, we will end up with about -16 dBm received power, which will provide us with a 15 dB fade margin.